Mark Bowie gave that great presentation. He wasn't able to attend the another SBAG meeting that was held in Pasadena, California in January. But since we were in Arizona at the time, I decided to attend it. And so anyway, while I was there, though, we had a side meeting up at JPL, which was only a few miles from the hotel where the SBAG meeting was. JPL people to kind of organize made local arrangements. But anyway, so I made this presentation to talking about the improvement of asteroid orbits for and with asteroid occultations. And I've updated it for this meeting, but I gave this as a kind of a presentation as a background to the JPL Horizons team so that they could see what problems were that we had and how they could help us with the orbits. So in attendance at that meeting, or everyone who's underlined here, it would have been great to have Dave Harold talk with us at the time, but he was in Antarctica on that trip, completely out of contact. But you can see, we had 3 people from the Horizons team, and Paul Chodas also chimed in a little bit. He was at the SBAG meeting, so I did talk with him. But we had Mark Bowie had a lot of good comments during the telecon that we had with us. We set it up on WebEx and we were able to go through it. And of course, Steve Preston too. So it was nice to have the main players in our prediction process there. So anyway, outline, I'll talk about, I just gave a quick introduction about observing occultations, about how we do it, and then I talked about improving the orbits for asteroid occultations, what might be done. I went through the 2019 Phaethon occultations, so I'll skip that here because I just talked half an hour about it. And then I talked about other occultations that have been improved with Gaia. I mean, we were in contact with David Fornotia and John Giorgini, before this meeting, so they knew some of the issues and they helped us. Because after the Phaethon occultations, we said, "Well, help us out for a couple of these other occultations too, and we'll see what we can do." We talked about the Swiri occultations by both Erikoth and Lucas, and further improving orbits with asteroidal occultation observations, and then we talked about other NEO occultations, how small might we go, future occultations needing improvement. So anyway, I gave this just showing and sort of made the point that this was the best observed event in 2019 has been mentioned, the Sylvia occultation. Dave Harold discussed this yesterday. In Europe, they have many more observers than we do. In the US, we can keep up with the Europeans only by doing multiple station deployments. And by a few of us succeeding in deploying multiple video stations, we've actually, as David's statistics showed, we were a bit ahead of the others. But anyway, this just showed the worldwide total. It was 430, at this point was over 4,000 occultations, but more than half of those were only one chord, and so showing the other statistics here. And so anyway, the accuracies that were determined, the very well observed events, the best well observed events determine the accuracy of the position relative to the target star to less than a milliarc second for 550 events, to less than 200 milliseconds for another 200,000, and for 300 milliseconds for more. So, but those numbers are a little bit optimistic, as I'll point out later. This was just from some statistics that Dave Harold had that I had time for the meeting. This just shows the Antiope occultation, the best observed occultation we've had in the past decade, really, nicely resolving both components of this binary asteroid. And the red giant star LQ Aquarii, well, it just shows tooting our horn, and I showed this slide showing how we do remote stations. And anyway, I pointed out also the occultation by Psyche, and Psyche is important because it's the target of the of NASA's space mission. So as you say, we got this. This was talked about. Dave Harold showed this very great fit of observations. This was well observed, mostly observers in Arizona, a few in California. My own efforts was to get observations near both edges of the path, and with help from other observers on paver stone mounts. Those were the three southernmost chords, and the three northern, or three of the four northernmost chords were our observations up near Kingman. Anyway, but then back 9 years before, we had another very well observed Psyche occultation, and I went to Texas to observe that, and got 4 or 5 chords in that one. Paul Maley got a few multiple events. And other observations were actually made in other places, including Steve Conard in Maryland. But the two models, shape models, fit are different. I mean, they have really good fits, but so there are some issues to be sorted out here to get a shape model that fits both occultations well. So we're partway there with two different models that fit, but the others don't fit as well as when you go vice versa. And then another issue was talked about a little bit about negative observations. When you set up, we made this deployment for the December 17th ISCO occultation, and we set up 4 mobile stations. We didn't get to the southern one, so we don't know what happened there. Wayne Thomas observed in Florence, so we had good coverage across the, at least from the southern limit to the northern 1 sigma zone, and no one had an occultation. So but there were still sizable errors. The JPL path, Horizons path, is shown here, in pretty good agreement with Steve Preston's predictions. So this star had no issues with Gaia DR2 data. I pointed out that European and UK observers had a similar experience with the 2027 January 7th occultation by Abnova, but in that case, when we went back and looked at the details, there was this big flag from the Gaia DR2. I mean, although the star has small errors, it said the geometry was bad for the astrometric solutions, and that translates into what's called RUWE was high, and that's the terminology for it, which just means you probably can't trust that solution. And for Abnova, that particular event, that turned out to be the case. And they covered from pretty well both 1 sigma limits with their observations. So if we're going to do a multiple station deployment, it'd be better to have the paths improved, maybe by using the Gaia DR2 data, which is difficult to use because they're only very accurate in one direction. With the way the Gaia satellite scans the sky. For stars, they're in one place, and so you get cuts in different directions, and you can get great solutions. But for moving asteroids, you get one point in one place, and then another direction accurately, and halfway around the orbit, or so. It's a problem to make the fit, although you have lots of observations. but the JPL Horizons team has figured out a way to do that, and they've partly in the past couple of months, they've managed to automate the system process to some extent, not completely, to help with our orbit updates. So anyway, this just talks about improving the history of orbit improvement, which David Harold sort of talked about in his slides. I'll also mention, then Gaia DR2 was best, for 2016, where we really have had essentially perfect star positions, except for when there are those flags. You have to be careful. We've had several successes by using an earlier first observed occultation in a given apparition to improve later occultations in the same apparition. Because the Gaia star positions are so good, once you get an offset for the orbit, for one, you apply the same offset to the next occultation. We had one time when we had 2 occultations within a week crossing Maryland in 2017 November. And all this was discussed in JOA in this particular article that I talked about in past meetings. And then I talked about Phaethon. We don't have, since we already talked about that. Then JPL increased the improved the orbit for Pandora. We would have been, I think we would have been too far north if they hadn't done that. So they improved it with Gaia data. But actually the final path was almost the same as Steve Preston's prediction, and the path shifted a little bit farther south. But they had smaller errors than, so that we were more confident that we would have hits by deploying for this event. The actual path was about 1.2 sigma south. Our Roger Venable had 4 more stations. These are chosen stations in Texas, but you can see we did quite well in recording this occultation. So we gave the JPL prediction, although it was similar, it gave us more confidence because of the smaller error bars with Gaia. And this shows, so we tried to do this with a small asteroid, 1400 Chirilla, which is about, I think, yeah, it's about a 20-kilometer asteroid, but it would call it a 5th magnitude star going across the Phoenix region. And so this shows the prediction, and this was updated with the Gaia data, and that gave error bars that were still, though, almost about a path width. But this shows our deployment here. All the red ones here are stations that had misses. And these are our numbered stations. We set up 13 stations for it. Station 2, for instance, the telescope blew over. Station 3 recorded a miss. We had a wind develop just 2 hours before the event, after we had deployed most of our stations. And so 2 of our telescopes were actually blown over, mighty minis, and 2 others, the telescope was rotated by the wind off target. But we did get successful miss observations. We ended up at the top, at the more distant stations. At the end, we should have done it the other way around, because the last stations you set up on are the ones that are more likely to succeed, because there's shorter times for things to, less time for things to go wrong than the earlier stations. But anyway, we did have one station which got a 0.4 of a second occultation, and then Reeves Parker got an occultation, and our station 3 had a miss, giving a good constraint. And this was a barbarian asteroid. I didn't realize that before the event. It's but anyway, then the interesting event, and it showed the path shifted 0.7 of a sigma north. So the JPL prediction was verified that. And then this occultation by Arakoth, MU69, from the Argentinian campaign in July 17th, I think it was 2017, showed 5 chords that fit very nicely the shape model for Arakoth that was determined after the flyby observations. But this sort of gave high confidence that Arakoth was a contact binary. And of course, the observations showed that so well. They had to use, it was very remarkable achievement to get 1 millisecond accuracy in the prediction. It was possible using HST observations, which is the only thing that could see this faint, this target 27th magnitude. And Gaia pre-release data for DR2 for the target and reference stars. Another SWIRI effort was for this occultation by Lucas, showing the several hits for that. And this was a SWIRI prediction, not a JPL one, but based upon some past occultation observations, there was a 1.5 sigma north shift from his prediction, and we got good data, but didn't get a missed chord to the north. The Pluto occultation, Lucky Star Project is doing this too with past occultations that have been observed by Pluto and reanalyzing them with Gaia DR2 data. And this, the August 15th, 2018 occultation was predicted to, the actual path shifted only about 8 kilometers north of the final Lucky Star prediction. So that was really remarkable. I mean, they assumed the uncertainty was about 100 kilometers. So we covered at about 10-kilometer intervals with large portable telescopes the central path. And 2 of the Virginia team had very strong central flashes. And I think the one SWIRI team had the largest central path at 10 kilometers north of center. Anyway, we should be doing this for our own occultations, but it's been complicated. David Harold has been supplying astrometric positions from occultations to the MPC for many years, but they don't report positional errors in their system. So they're being thrown in with all these really poor Earth-based observations with accuracies of 1/2 of arc or 2, whereas we're getting millisecond arc accuracies in our occultation determinations. So the value of our observations are greatly diluted. JPL just uses a standard 0.2 seconds of arc for their errors, because the occultation source is identified by the MPC, but not their actual errors. It's still 200 millis arc seconds is much larger than our errors, and Steve Preston has done a similar thing. So what we really want to do is to use the tiny errors in these occultations, and then the occultation observations will dominate the solutions when we have enough observations. So far, we're just not using them to the accuracy they deserve. So that's not happening on a routine basis. The JPL Horizons team, though, is doing that with the help. This is the David Harold's offsets and accuracies that he determined for. He's done this for all of the occultations and generates this list. With these uncertainties determined from the occultation at the milli-arcsec level. Of course, if you have only 1 chord and it's kind of a short chord. The uncertainty is the full diameter of the asteroid, and so the uncertainties from the occultation reflect that. So this is a very long table. I've cut it apart into the left side and the right side for these two occultations. And is important, that's the number of chords for the occultation. This table, though, needs some more work because the errors for most 2- and 3-chord events are very small. You just fit an ellipse and it has a very small accuracy, but the real uncertainty is considerably larger than that. And David Harold, in a paper that he's preparing for publication, goes into this and has a scheme now for giving more realistic error estimates for the 2- and 3-chord events where the geometry isn't best, and giving higher weight than giving the full accuracy to the 4 and more chords where there's good distribution. But currently we have smaller errors than are really called for some of the events. But then the other thing that's important are the 2 flags that sometimes the Gaia 2 gives. I mentioned the high RUWE, which is a poor solution flag. And there's also a duplicate source flag, which sometimes indicates the star might be a very close double, or they see evidence of that. We found often from our occultation observations, they're not really double, but it does mess up the astrometry when that happens. So the positions of the stars are off a bit. And with the high RUWE, they can really be off. So for those events, you want to exclude them or give them much higher errors than the formal star accuracies imply. I mean, it shows very small errors, but when the RUWE is high, we show later that you can get like 40 milliMOS errors. Well, this was something I just had some occultations since then that JPL has also improved. So we'll just quickly go through this. This was the brightest occultation of this year, but it was too cloudy to really try to go after it. This was a nice 7th magnitude event where we traveled up to Colorado to observe it from locations east of Denver. There was a large shift to the west in spite of the update with the Gaia data, but this was likely due to, we thought it was due to a duplicated source flag for the star in this case. However, later that month, there was another occultation in Arizona of a 13th magnitude star, and there was a similar shift. So in spite of there was no duplicated source flag for this star. But however, this was near a stationary point in the sky where the apparent motion of Abnoma was nearly north-south. And there's problems in that geometry, even with Gaia observations, especially because Gaia observes about 90 degrees from the sun. So they don't observe near opposition like most astrometry is done. And also at that point, then the asteroid is unevenly illuminated. Dave Harold mentions that in this paper he's describing. And so the Gaia position is offset from the center of mass because of the center of illumination, because the asteroid is maybe half or a third dark. But what it sees is what's the sunlit part. So that might cause some of these problems why we, when we're trying to get predictions that are more accurate than the diameter of the asteroid. This just shows Caprera. This was a high RUWE event, so we made a big effort to observe it. We knew that we were in trouble, that there might be a large shift, and there was. We had about a 4 sigma shift from the nominal prediction. We had the JPL orbit update, but the star position was much worse than given. Dave Harold made a better prediction for the path using only UCAC 4 data, just ignoring Gaia completely. And any of the Gaia data shifted the path farther north. This was a molestation effort by Ted Blank and us, and Ted Blank got 2 hits with the southernmost station. Here's the predicted center line. Here are the 2 hits that Ted Blank got, and several other miss observations then across the path. And then also in Arizona, we had an occultation of this 5th magnitude star by Padua that was also updated. The prediction was quite good in this case, in spite of no Gaia data being available for the star. It's too bright, but the HIP data was good. And monsoon clouds, though, prevented along the mountains, obscured observers in the northernmost part of the path, so we didn't get everything. And the path shifted a bit north, so we missed the south too. Then more recently, we had the Josephina occultation. In this case, the prediction was really great. This involved not any of the Gaia data, but several past observed occultations that the Horizons team analyzed using the unrealistically too small errors of some of the past observations, but still they got this great prediction by greatly weighting the occultation observations over all of the other traditional astrometry, which is so much less accurate. Then an hour later, we observed the Laperta occultation, where the path shifted more than a path width to the south. We didn't know if we'd get it or not, but we did. This was just from a low magnitude feed prediction. It doesn't even have a Preston update. So, of course, the prediction for that event was much less accurate. But for us, it was important, to me anyway, because it was the first time that I've ever observed 2 asteroidal occultations in one night. Many others have done this before. And as I pointed out before, this was only a day before our anniversary. And then tonight, this is another JPL update for the occultation by Turandot of a 10th magnitude star. We were hoping to observe it from central Texas with the IOTA meeting, but now we're too far from the path to travel to it. There are a few other mobile observers who are trying it, and a few fixed site observers, so we wish them luck to see how well the JPL prediction goes. We should know soon. The predicted weather should be quite good from central Texas to central Ohio, maybe northern New York, not sure. Anyway, further improvements then, MPC is adopting this new format, ADS format, that will finally give error information for the occultation astrometry events. And it will handles gravitational deflection and other small errors and so forth. And then we talked about other neo-occultations. We have the Phaethon experience now. We know that this can be done, and we got predictions down to the 1 kilometer level, so we might be able to predict these small objects. We can't get very good shape or size information with these small objects, but we can get great astrometry. And for instance, Paul Chodas is interested in Sisyphus occultation. That's about a 7-kilometer asteroid. What's happened? Did I just, your interconnection is unstable, it says.
I've got it back again.
Okay, now can you hear me?
Yes.
Okay, sorry. So we just had an internet hiccup here. So Joan, if you have your video on, turn it off. Anyway, so we might be able to do some of the larger NEO occultations, so we should start looking at those. But anything we get would be great for the astrometry that would be used to update their orbits. And anyway, asteroids that have been updated in the past by JPL, we have good orbits for them now. We should use them for future occultations. And this is the list of them that have been updated. Lucas one by Swery, but for future predictions, they have these special accurate updates, but we found sometimes the orbit solutions are erased by later automated updates. Both at JPL and Steve Preston have ways of doing that. And we had that happen with Abnova, and we said, hey, wait a minute, I thought this was an accurate prediction. And they said, oh yeah, oops. and so they restored the good prediction and kept the work that they'd done before. So these all have better orbits now than in the past, and but we still have to incorporate the very latest occultation results into them to get them even better. But we'll do that in time in our system. So every few months, David Harold updates the astrometry to. The Lucky Star Project is doing similar work for Trojan asteroids and more distant objects. So of course, I showed them the Plutos, which was so spectacular, but they now have Quorar pinned down quite well, and a few of the other TNOs. Anyway, more to come, especially as we process. The process became more automated, and but this is the things we can do now before Gaia DR3 becomes available more than a year away from now. This was just something I gave for them, the future occultations, and but they're past now. So that's the end of my presentation. I hope I'm not sorry. I'm pretty much on the schedule that I thought I would be. With that, I'll open it up for any questions.
David, what was the purpose of that cable in your wedding picture?
Oh, yeah, there's a whole story about that. It was for grazing occultation to, in those days we were observing visually. So each observer would go out with a tape recorder and a shortwave radio. The toll pole now are the video time inserters. In those days, the toll pole was a shortwave receiver. So many observers wouldn't have that thing. Radio Shack kind of came to the rescue with their time cube, which shows for $40 you could get this device that would give accurate audio time signals. Unfortunately, they stopped manufacturing those, but you can still get shortwave radios for about $50 that do pretty well. But GPS is so much better and more convenient, especially for video work, where it's. But anyway, the cable was set up because most observers didn't have shortwave radios or even tape recorders in those days. So they said, well, let's, the phone, they knew that the phone company was throwing away gobs of cable that were, come down in storms and different things. And so they could go to landfills and pick up, huge amounts of cable. They said, let's just connect tone generators to these cables, roll the cable up on a spool, like you saw there, and run it down the road. The stations for lunar grazing occultations, you'd cover about a mile or maybe a mile and a half or so. And so you could have cables, most of them were, the Milwaukee cable was 2 miles long. And they had 20 stations set up on it, and a 21st station where 20, and they had it set up to a pen chart recorder. The observers would hit a button whenever they saw an event, and they'd hit it twice with, for a D, and then hit it twice for a reappearance. And then one of the channels, though, was the pen was run from the WWV time signal at the central station. So that provided the timing for all the observers. So there were 5 of those cable systems were manufactured, 3 in California, and the Milwaukee cable, and 1 at the U.S. Naval Observatory. But of course, they were quite a pain to deploy, quite an effort to set up, and and with the value of grazes declining, their uses. I think the Milwaukee cable is still in existence. Some of these cables are, but they're museum pieces now, or they've been taken apart for other purposes, maybe just for the copper.
That's a wonderful picture. Do you mind if I share that with my astronomy club when I next do a presentation on occultations?
Oh, yeah, all this is publicly available. Sure, that's use it as you want. And so, we'll now these 3 presentations I just gave are actually posted on a website that I gave a link to a couple of days ago in an email message. But this particular presentation that I just gave has been updated quite a bit from what's posted there, but we can update it soon this week, and we might put some of the other presentations there too. But we need to do this in a more organized fashion with the IOTA website. So we'll work on that at the end of the meeting. Anything else?
Yeah, this is Ted Swift. I have a quick question going back to your previous presentation where you were saying that professional astronomers are getting more interested in the use of occultations. I've had some challenges getting some local research observatories interested in doing some of the more valuable TNO events. They just kind of brush off that pro-am collaboration. Can we start working on collecting resources for convincing the professionals of the value of these professional amateur collaborations?
Yeah, so I think Mark Bowie's presentation at the SVAG meeting was a great start for that. I encourage you to look at that and download it, and you can use it to show these people. One of the things I think Bill Hanna found out that there are lots of remote observatories all over the world which are doing great work in astronomy, but all of them, none of them have accurate timing. All of them have timing by NTP if you're lucky. And there is a need. Bill Hanna was trying. His first idea was just to try to rent time on a remote observatory, but when he saw the timing problem, that we just couldn't get the accurate timing we want, he decided to order this plane wave telescope and have it set up in Yass, Australia, where the weather is so much better than where he lives. But I think the first step would be to try to convince people whenever they set up a telescope, they should think about timing and some way of getting 1 pulse per second GPS timing into their system. Either the QHY is the only camera that has that, the only digital camera that astronomers are using. And that's why the professionals like it so much, because it has great flexibility and the way you can take data. But it's more expensive. But if they could at least, maybe some of these observatories could just, purchase an IOTA video kit, for $518. It's a very small cost compared to the financial investment of the observatory. It would be, great to get more observations from these places and convince people that, as you say, that that this is work that should be done.
I'll also mention, Ted, that Dave Harold is working on a paper now that should show up in the next month. I'm guessing that's sort of a guess. I expect he might have it done within a month. And that paper summarizes a lot of the results that have been achieved with occultations. And to some extent, this is meant to be a good data point to reference to let everybody know just what can be accomplished via occultations. That it goes over diameters, goes over a little bit on astrometry, double star, and a few other, and it's kind of an overall review of some of the accomplishments being done with occultations, and that will be a good thing to reference.
Great, thanks.
Okay, if there are no more questions, I guess we'll go on to the next presentation.
Okay, I'll hit my stop share button then.
Okay.
Let's see.